The goal of this video is to get you ready to do your lab investigating isotopes. And we're going to watch a little bit of this Tim and Moby together. How can two atoms of the same element have different numbers of neutrons? That's what Gabriella is asking Tim and Moby. So the idea again is isotopes, atoms of the same element with different masses. Isotopes, isotopes, atoms of the same element, have different masses or different numbers of neutrons. That's what our lab is going to be investigating.
Element have different numbers of neutrons. From Gabriella. Whoa, I think we've got the periodic table of elements handy. Let's look at an element as it's shown on the table. How about, though, say, chlorine? Cl is the symbol for chlorine. And this is its atomic number, the number of protons in its nucleus.
So remember,
the atomic number is what makes each element unique. Every chlorine atom in the universe.
So remember that the atomic number tells you the number of protons and the number of electrons. And that's a big part of your lab that you're going to be doing as well. You're going to be given the nucleus of an atom, and you need to calculate the number of protons and the number of electrons, and ultimately the number of neutrons.
Atomic number, the number of protons in its nucleus. The atomic number is what makes each element unique. Every chlorine atom in the universe has exactly 17 protons. One more or one less, and it becomes a different
element, is what he was about to say. So remember that the number of protons, the number of positive charge inside the nucleus, tells you what element it is. In this case, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If you have 16 protons, you are sulfur. If you have 17 protons, you are chlorine. The number of protons is your defining characteristic. It tells you what element you are.
Different element with totally different properties. The number of neutrons, on the other hand, can vary.
Why did Moby's head pop off? Because the number of neutrons in an atom can vary. Atoms of the same element, chlorine atoms, protons has to equal 17. The number of neutrons can vary. You could have 18, you could have 14. The number of neutrons can change, but in order to be chlorine, you have to have 17 protons. Atoms of the same element, two chlorine atoms, both have to have 17 protons, but they could have different numbers of neutrons, giving them different masses. These are called isotopes. I-S-O-T-O-P-E, isotopes.
Protons and electrons. Neutrons have no charge. We know that opposite charges attract and like charges repel. So, ever wonder why all those protons in the nucleus clump together instead of flying apart? The answer is neutrons. Protons just enough to overcome all that positive charge. So you can think of neutrons as a kind of glue for the nucleus. But there's always more than one way to glue a bunch of protons together. Depending on how they randomly stack up, they might need more or fewer neutrons to keep from flying apart. That's why all elements naturally occur in isotopes, atoms with different numbers of neutrons. Chlorine has two natural isotopes, chlorine 35 with 18 neutrons, and chlorine 37 with 20.
Hey, Sleepy Steve, wake up. This is it. This is the point right here. What is this called? I-S-O-T-O-P-E-S. Wake up, listen. 17 protons in both of them. That's what makes them both chlorine. They have different numbers of neutrons, 18 in that one, 20 in that one. That's why the mass is different. 17 plus 18 is 35. 17 plus 20 is 37. Atoms of the same element, chlorine, with different numbers of neutrons. Those are isotopes. Isotopes are atoms of the same element with different masses. That's what our lab is going to be investigating.
We identify them by their mass numbers, the sum of their protons and neutrons. Conveniently enough, those numbers also tell us each isotope's mass, 35 and 37 atomic mass units, or U.
In your lab, you're going to be writing this two different ways. You're going to be representing these like this in hyphen notation, CHLORINE, chlorine 37, or you're going to write the nuclear symbol. Cl is the element. The mass number will go on the top left, and the number of protons goes in the top right. This is how you would write the nuclear symbol for chlorine 37. This is how you would write the hyphen notation for chlorine 37.
The two isotopes are basically identical. The only difference is that Cl37 is heavier from its two extra neutrons.
Why did the balance go down on this side? They're both chlorine. They both have 17 protons. Cl, 17 protons. But this one has 20 neutrons, and this one has 18 neutrons. So this one is heavier. Its mass is 37. The mass of this one is 35. Isotopes. How do you pronounce that? Isotopes. Isotopes. And that's all we're going to do with this Tim and Moby. We got stuff to do if I can figure out how to get out of here. So we're going to talk about your lab. So continuing on in your lab notes fill in, this is the part where we're going to look at the paper you're doing for your lab. What you're going to have is different bags with spheres inside them, and those spheres represent protons and neutrons. You're going to fill in information about the particular nucleus. Each bag represents a nucleus. Each bag represents the nucleus of an atom, and you're going to fill in information about each atom in a table. The nuclear symbol, as I said a moment ago, the nuclear symbol tells you the information about a specific atom. A specific atom. The number on top in the nuclear symbol is the mass number. The number on the bottom is the atomic number, and you've got the element symbol. And here that is again. The way that we write this is the element symbol, and then the mass number goes on top, and the number of protons goes on the bottom. So if it was a carbon atom that had 6 protons and it had, say, 7 neutrons, then its mass would be 13. So this would be the nuclear symbol, nuclear notation for carbon. And we're going to practice this. That's the point of the lab. So you're going to get different bags that represent the nucleus of different atoms. Here's an example of one. We're going to make this A. So black spheres represent protons. So we got to count the black ones. 1, 2, 3, 4, 5, 6, 7, 8. And you should be filling this in on your paper that you have. 8 protons because there are 8 black spheres. Blue, or it looks purple in the picture, blue are neutrons. So how many of those are there? 1, 2, 3, 4, 5, 6, 7, 8. There's also 8 blue ones. So we've got number of protons, 8, number of neutrons, 8, number of electrons. If this isn't an ion, which we haven't talked about yet, so we have said so far that the electrons always equals protons, so 8. Now we need to know the mass of this particular nucleus. 8 protons plus 8 neutrons is 16. So our mass is 16U or 16 AMU. Look up the element name. Element number 8 on the periodic table is oxygen. Now we got to write the nuclear symbol. O is the symbol for oxygen. The mass goes on top. Here's our example, the one above it. So the mass is 16, and the number of protons goes on the bottom, 8. So that would be our nuclear symbol for oxygen, and then hyphen notation. I've got such a wide pen here. O, X, Y, G, E, N, dash, mass. The mass number 16. This is how you're going to do this in your lab. We'll do one more practice. If you need to watch it again or slow it down or pause it, go ahead and do that. But I've got one more example. So this one we'll do as B. I love this green color. We're going to do B now, I think. Here's B. So we've got to count the protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 protons. And now we've got to count the neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We've got 15 neutrons. Does it look like I missed any? I don't think I missed anything. The number of electrons should equal the number of protons for now, so 16. The mass is 15 plus 16 protons plus neutrons gives you the mass. 16 plus 15 is 31. Element number 16 is, I don't want to do that. How do I go back? Is there a way to undo it? Yeah. Element number 16. Anybody know what element number 16 is? Let's see. I had a periodic table up here somewhere. Number 16 is sulfur. That's what I thought. We just had it in our video, but I didn't want to tell you wrong and have to redo this whole video. So our element is sulfur. Sulfur. Yes, it is 16. All right. What am I doing? Sulfur. And so the symbol is S. The mass is 31. The number of protons is 16. Sulfur 31 is the hyphen notation, name slash mass. And here's the symbol, mass top left, number of protons bottom left. And that's all you should need to do to know to finish your lab.